Welcome to the Maintainable Software Podcast, where we explore the art of improving existing software with seasoned practitioners who have helped organizations overcome the problems often associated with technical debt and legacy code. I'm your host, Robbie Russell. On this episode, Tanmai Gopal, who is currently a co-founder and CEO of Hasura. Tanmai joins us from San Francisco, California in the United States, in North America, on planet Earth, in our galaxy. Tanmai Gopal, we're so glad to have you join us on Maintainable. Welcome.
Hey, everybody. Thanks for having me, Robbie.
So as you reflect on your experience in the industry, what do you believe are a few common characteristics of, dare I say, well-maintained software?
It's a loaded question. I'm not going to cop out by saying it depends on what you're building, but there are a few kind of universal characteristics, I think, that I've seen in practice. The biggest one that I try to often work backwards from is the idea that there should be no part of your code base that people in the team are afraid of. So ensuring that any kind of bit of the software that you're building is accessible to people, and people can iterate on it and people can understand it, is what we all want to achieve, right? Like, you wake up tomorrow and you look at code that you've written 6 months ago and you're still able to work with it. It's well-maintained software, right? But oftentimes that's very hard to measure, right? Like, understandability is hard to measure. How much documentation is enough is hard to measure. But one thing that is easy to measure, qualitatively at least, especially as you're working with engineers and as you're working with each other and you're working on the code yourself, is how afraid are people of a certain part of the code, right? So if people feel like they don't want to touch a certain part of the code, they don't want to modify it, they try to work around it, and nobody wants, like, that kind of stuff, that is the least amount of code that you have that's like that, and preferably zero. That to me is a big sign of, like, it's a well-maintained code base, which hopefully correlates to well-maintained software.
Yeah, I'm also thinking about you think about like horror films. Go with me down this tangent for a second. My perception of what a scary movie might be very different than yours. So it feels subjective or very personal. I'm not gonna say preference, but how, like, whatever led them to be the person that they are. So how do you think of, are there actual, say, kind of qualitative, traits there, or things you can measure? Is it just that there's a very little, that area of the code base may be rarely changed, or is that a way to tell that? Or is it that just people tend to throw their hands up, and it's either, there might be people listening might say, like, a counter to that, well, I'm just not familiar with that older approach or that older piece of technology, and that's why we're afraid to touch it.
But these are all valid reasons, right?
Yeah.
And these are all valid reasons, and these are all pointers of saying that this is not well-maintained software. Because if somebody says, I don't want to touch it because, that's now an action item to make your software more maintainable, right? But the way that this pops up is, it's very easy to see that this pops up because when you're in a sprint or you're planning out work or you're looking at backlog, it's very easy to look at an item and says, why is nobody taking this item up again? Or, like, why does nobody want to take it? Or, like, it seems like a simple enough task, like add a dropdown. But why do you not want to add a dropdown in this particular UI component, right? Or why do you not want to modify this algorithm that does this complicated, like, merge, right, of some data structure? And that's very easy for a team, a code reviewer, an engineering manager, anybody in your team to kind of watch out for. And it's an easy enough and intuitive enough principle also to kind of put across your team, saying there should be no part of the code that we're afraid of. And as people start to kind of internalize that concept and watch out for it and talk about it with each other, it kind of creates this culture of spotting parts that are not well maintained and actively working on maintaining them. I think it's subjective, but it's subjective in the right ways, in the sense that, because ultimately, what is the purpose of well-maintained software? It doesn't really matter, right? It's not like somebody pays you money for well-maintained software. They pay you money for software that works and, like, drives the business forward, right? So the true kind of indicator, like, what you truly want to achieve, is being able to actually work with your software and ensure that it's high quality product and stuff like that as quickly as possible. When you think of all of those metrics, right? Like, how do you know that your product or software is high quality? And the answer to that is, that's even harder to answer, right? Like, what's the quality bar? And so what we often fall back to are things like DORA metrics, right? Where we say, wait, maybe quality is hard to measure, but if we can get MTTR to be really low, and we can get, like, deployments to be really fast, then at least we know that if we ship low quality and we change what we mean by quality, we can ship a change really quickly. right? But to achieve all of those positive DORA metrics, you need well-maintained software. And to achieve well-maintained like software, which is this North Star, nobody in your team should be afraid of any part of the code that they look at for whatever reason, for all of the reasons that you mentioned. But ultimately, it is a human condition is, man, I don't want to touch this code. whatever is causing that human condition to exist. So that I feel like has been like a strong invariant for me to think about even productivity of teams and health of the code base and stuff like that.
What is your current take on the metaphor technical debt? Do you use it very often?
Yeah, it's a good thing to think about. I've used it very, very often, and mostly from the point of view of telling people to not talk about it. Like, don't use the word technical debt. Don't say technical debt. And the reason why I say this is because I think all code that you write is like tech debt in some form or the other. By almost by definition, it's really hard to have code that doesn't at some point become tech debt or the other, right? And so I feel like if you think about like from a product prioritization point of view, right? Or you like, I want to get some stuff done. I want to put 20% of my time on tech debt issues. I want to put 20% of my time on innovation. I want to put 50% of my time on bug fixes, right? For user-facing bug fixes and stuff like that. And you try to allocate time like that. I think it becomes really, it's been complicated to operationalize that, right? It's been what it is, but it's really hard to actually think of like work time as broken down as percentage points, right? And saying
very much, yeah.
It's
easy
like
easy to say it, but it's like
very easy to say it, but it's just impossible to actually do it. And so, like, I've not enjoyed that framing. I also don't like sometimes in the way that it creates a certain kind of culture for us as in engineering sometimes, which is that I want to clear out a lot of tech debt because best practices, right? As opposed to I want to clear out tech debt because product outcomes. I always prefer that kind of framing, which is always I want to clear out tech debt because product outcomes, not I want to clear out tech debt because best practices, because there's no such thing as best practice. I mean, there is, but it's always contextualized to your team and your product and your culture, right? So it's very hard to, you have to take best practices and contextualize them. So it's if you create this culture of saying let's keep fixing tech debt, then people will just go off on a tangent and keep doing stuff that feels very productive. People are continuously shipping, people are like breaking up their complex body of work into tiny pieces and like first fix tech debt, first do this, first do that. The framing that I've preferred on tech debt is always that leave the campsite cleaner than you found it. Kind of thing. Like that's always been a better way to frame it, which is to just say, if you're building something and you're looking at code and then you look at that code and you don't like for whatever reason, you feel like I'm going to look at this code in the future and be afraid of it because it's not tested or it's not documented or this algorithm is buggy, it doesn't capture edge cases. Just clean it up then and there. And now you can kind of start to think about it more as a bug fix or a feature enhancement that you're doing, and you're cleaning up tech debt in the context of ultimately delivering on product outcomes. This takes care of a chunk of technical debt type issues, right? Then there are like large technical debt issues, which are architectural debt issues, which is like, man, something is fundamentally wrong with our code base, right? And that's a whole like that's a whole other beast, but we can talk about that, but that's a different kind of technical debt almost.
Hey folks, it's me, Robbie. I want you to take a moment and close your eyes. Now picture your code and your applications as a symphony. Now to keep that symphony playing smoothly, you need an orchestra of tools. That's where our podcast sponsor, AppSignal, takes center stage. They combine the elegance of error tracking, the precision of performance monitoring, and the harmony of logging into one symphonic suite. Whether you're composing with Ruby, jamming with Elixir, orchestrating with Node.js, or harmonizing with Python, or maybe even a little bit of flourish of JavaScript, AppSignal's got the sheet music for you. And here's the crescendo. Plans start at just $23 US a month. That's gotta be music to your budget's ears. Plus they're certified ISO 27001 and they dance the GDPR and HIPAA compliance beats. So don't miss a beat, my friends. Head on over to appsignal.com and tell them that your good friend Robbie from Maintainable sent you. Now, open your eyes and let the symphony of smooth coding begin. Let's get back to our show. Where do you classify something like version, like keeping things updated with latest library versions and things like that? Is that something you would classify or discourage people from considering calling that technical debt versus just a a task that needs to be done.
I would say like it should again be attached as closely as possible to a product outcome, right? So for example, security vulnerabilities and high like it's an outcome that's important for you. Maybe it's not an outcome that's important for you for something that you're building. It's an internal application. Who cares? Security vulnerabilities are not important for, I mean, I should never say this. Internal applications also security is important, whoever's listening. But if you work backwards from that, it really helps kind of prioritize, right? So you run a vulnerability scanner, you know, like I need to fix these dependencies. This is like high priority, must do, right? Or the nature of my software, it sits in the critical path. It's important to fix, so I need to update them. And from the other point of view, which is kind of leave the campsite cleaner than you found it kind of situation, right? You're working with something, you come across an update that you ought to make to a vulnerability, make the update, right? Like as a part of that thing, make the update, look at, see if it breaks things or doesn't break things and what the release notes are like. And if you feel like it's safe to make the update, go for it. Right? Or if you feel like the maintainer is saying, listen, this is not going to be supported like 2 months from now, make the update. But you don't have to proactively think top of mind, oh man, my dependencies are out of date. I'm going to wake up in the middle of the night and sweat about it now. I don't think it's necessary.
And I think that like assessing the risk on the security thing as well. Maybe as you said, mentioned, like there's plenty of examples where it's like an internal facing thing. And I've been in client calls where maybe a developer's like, we need to get this updated because I'm like, well, who's penetrating your internal network? And then if they're already in your network, somehow the
Bigger
guy
fish to
from
fry.
VPN, you got way bigger problems. Yeah. So if they're managed to do some sort of cross-site scripting at that point, like they just have too much time on their hands. And let them have
Yeah,
fun.
exactly.
All right. So one of the things I wanted to talk with you a little bit about and why we have you on the podcast is to talk with you about this concept called the super graph. So
Yes.
for some of us laymen's out here, can you break down the concept of a super graph architecture for us?
Absolutely. So for those of you familiar with GraphQL and have been using GraphQL, you've probably come across the word supergraph, right? The word supergraph itself, I think, was one of the first version or iteration of the GraphQL effort at Facebook was dubbed supergraph at Facebook. And then later on, as it kind of took shape as a API specification and protocol, the team launched it as GraphQL. The supergraph is now kind of in common parlance used to refer to this idea of federated GraphQL. So this idea that you have a unified API that is created by little smaller pieces of the API that are independently maintained by different teams, right? So think of it as a giant API that has, say, 100 endpoints. But let's say 10 endpoints come from this team, and 20 endpoints come from this team, and 50 endpoints come from this team, and 20 endpoints come from like whatever fourth team, right? And that kind of coming together in that unified API, that process, when people are kind of doing that with not just API endpoints, but with GraphQL, one of the kind of common words that have emerged to talk about that is a supergraph. What we've been doing is working closely with our users, our customers, with folks in the GraphQL Foundation and in the industry overall, to start to kind of really put together a reference architecture for what it means to create this unified API, how to operationalize it, how to think about a platform approach for maintaining kind of this reference architecture, right? And that's kind of what we call the supergraph reference architecture. I'll dig into it in a second, but does that make sense?
Yeah, I think I get that at a kind of a high level with the GraphQL, and like you can call different pieces of the different endpoints and stuff like that and connect it. And knowing that, I think as an API user, not really needing to worry about which, like there's different platform, APIs. It's like, hey, I can just call different things and get a little bit of information from here, a little bit from that, and let the API or GraphQL backend do all the work, and I don't have to think about it too
Exactly.
specifically. Like, as that is one of the challenges sometimes with like maybe a RESTful API where you're like, I got to pull some from this one, and then I'm gonna have to use a reference to go pull some stuff from a different endpoint. Does that really go away with GraphQL, or is it just like a little less of that?
Correct, correct. No, that's a very, very good question, right? And so I think it's worth kind of talking about Supergraph from kind of these 2 points of view, right? One is this idea of a unified API and an API that's facing customers, right? And the second is kind of this idea of GraphQL itself, right? Which is GraphQL versus REST or GraphQL versus gRPC and things like that, right? Which is like the specific pros and cons of GraphQL as a protocol. And that's kind of one of the things that we've been trying to do is also to talk about separating the protocol aspect a little bit from the idea that you have a semantic graph, like a conceptual graph of things inside in your API, in your databases, in your domain that are spread across things, right? Because regardless of whether you use a REST endpoint to access a user or a REST endpoint to access an account, the fact is a user has accounts, right, in a financial application. And so there is a semantic graph that exists for people when they think about, yep, user has accounts. And now the way that you access it, maybe there is a unique endpoint for accessing a user, a unique endpoint for accessing an account. Maybe there is an aggregate API endpoint that gives you user and accounts together, right? Maybe you're using GraphQL to fetch it on demand, right? That I want user and accounts and kind of want to aggregate them together and fetch them, right? Or I just want to fetch a unique slice of it. But I think first there's this idea of saying there's a whole bunch of API models or domain models, and these domain models can be connected to each other in a way that reflects what the business does. And that's kind of one element of the supergraph, right? Which is to say, you have a subgraph that has 10 models, right? And then somebody else has a subgraph which has another 10 models. And now there are relationships within the subgraph and between those two subgraphs so that you have a semantic supergraph. That's kind of one aspect of it, right? Which is missing today. If you, for example, went and looked at a collection of APIs that were exposed by an API gateway, for example, right? You'd look at it and then you'd like kind of scratch your head and you'd be like, wait, there's a user endpoint here, but there's like user with profile endpoint here. And like the word user is appearing in like so many places. Which one is the one that I want? And like, are they connected to each other? Are they just completely different concepts, right? There's so much overloading that can happen. That lack of understanding of how your models are connected to each other and what each are and what is kind of a system of record type of thing and what is derived data that is attached to that model, it's painful to kind of understand what is going on when you look at your system as a flat list of endpoints that just return data. So that's kind of one aspect of the supergraph. Does that pain point kind of make sense? And then we'll move into like GraphQL in a second, but like there's kind of this frustration with, I want to stop looking at a list of API endpoints and documentation in an Excel sheet or something.
No, it's true. I think and this is maybe just even just thinking about API documentation in general for a REST API endpoint or having that huge list of them. Like, I feel like more often than not, I just wish it was like the information could be a little bit better organized. Be like, you're most likely going to start here, and then you're going to be able to want to get to here, and then here's some stuff that's nested, and you end up having to try to like figure out like APIs. What is their backend data model structure look like? And I'm like, I just need to get some detail. I'm like, I have to know that there's all this stuff, like, and what do I really need? I'm like, I'm looking for like 8 different pieces of details about a user, and I'm trying to make sense of where it all. So please just like kind of guide me to like, here's the most common edge cases, and if you need to get deeper, down here. But anyways, back over to you. Like, so that makes sense. And then like if you go back over, like start thinking about that from a GraphQL and like why it exists.
Exactly, right. And so this kind of like this kind of semantic graph element of it that is critical to unlock like API productivity for people, right? Especially at any kind of scale where there's just too many endpoints that are starting to exist and you want more and more microservices to exist and more data to exist and like there's more API endpoints and it's a mess. So that's kind of one important side of this. Now, the second side of this is there's this great kind of conversation that I came across on LinkedIn yesterday, right? Which is like, so should our APIs be designed from the point of view of the domain owner and the producer? Or should our APIs be designed for the consumer? If you are my consumer, should I be like, hey, Robbie, like, what do you need? And Robbie's like, dude, I need these like 10 things. And I'm like, cool, I'm going to make these 10 endpoints. That's exactly what Robbie needs, right? Is that the principle for API design that we should follow? Or should I say, well, here's Tanmai, and he's the expert at understanding this user authentication domain or e-commerce inventory domain. And like, he's created this most amazing API that you can like look into and you can be like, this is exactly what the business is doing. This is great. But does it give you the data that you want for your use case in precisely the shape that you want? No, right? And so there's this tension. My API is easier to understand for anybody, but if I talk to you, then that API would be amazing for you, right? That'd be the best API that I could create for you. Now, this is one of those evergreen problems, right? It's like, what's a good API design, right? And so one of the things that when we think about particularly like supergraph architecture and layering on and using GraphQL as a protocol is to address this tension in a slightly better way. And to say that the base API that you create on top of any domain, or let's call it a subgraph, which is like a one domain that is a part of, like, say, 10 domains that come together to describe some part of the business, right? Mm, this particular domain or subgraph should expose a core set of resources and methods that are the best way of describing what that domain is, regardless of who's consuming it, in a way that any customer can come in tomorrow and really understand what it is, right? Especially kind of that graph and relationship element of it, right? So you're like, this is the user, and then the user has account, and then the user has past orders, and like it's very clear, it's very standardized. There's standard ways to filter and paginate and sort, and like, because they're all resources, right? So resources can have standardization on how you CRUD them. Then you have methods, and these methods are pieces of business logic that act on those resources. And so that's very clear to understand for any customer. So tomorrow you come in and you want to build an app, at least you understand what the API does. Is the API optimized for you? No, it's not. Are you going to have to make 10 API calls to get the data that you need for rendering one UI page? Yes, you probably are, but at least you understand the API very well. And you and I can have a very productive conversation about what something means in my API. So that's kind of layer one, right? So let's call that like the base API that you want to have. Now let's kind of talk about the consumer-facing needs, which is the second layer of API design. This is the part where we're thinking about when a customer and a consumer really comes in and starts to use an API, the most kind of typical items that you have in your backlog, that's the back and forth typically between an API consumer and API producer, is usually stuff like, can you just merge all of these things into one endpoint and give that to me? Like I don't want to make N+1 calls, right? And this is not efficient. Or like, I want to fetch this data, but I need to filter it by properties in that API model. Like I want accounts where the account owner is in San Francisco. And you don't have an API endpoint that does that. What you can do is make an API call to users, filter it by San Francisco, get all of those user IDs, and then make an API call to accounts, where accounts in user ID. Nobody wants to do that. That's expensive. That's almost impossible sometimes, depending on the size of data that you have. You can't do this like aggregation on the client side as an API consumer, right? You can't fetch like a gig of data. So now how do we create this API? Like we're kind of violating our idea of creating a base resource method oriented API by creating an API that's customized just for your use case. But if I were to do that, I mean, it's a slippery slope, right? I'm going to have to keep creating these aggregate endpoints for every single customer that I ever talk to, for every single use case that they have, right? Because you're like, so on my mobile version of the app, I want this aggregation, but I want only 10 fields because I don't have that much space on my screen. But on the web version of my app, I have a lot of space. I want like 100 attributes that I want to show the user. And now if I give you the same endpoint, you're going to get angry because you're like, nope, I want like a mobile aggregate endpoint and I want a web aggregate endpoint that's separate. Maybe you're not building an app, maybe you're building an external partner API. And for that, like your needs are different, right? So it's as soon as you start thinking about the number of consumers and each consumer having unique needs, you run into an API integration and aggregation and orchestration problem that sits above the base API. And this is the challenge that nobody really has a strategy around. And people just kind of like talk to each other, get angry at each other, send each other passive aggressive messages on Slack about, right? It's like, this is the thing that, like, if we separate out the base API versus the API integration, aggregation, orchestration layer, right? It allows us to think about it neatly. Now, I'm not saying or advocating for the fact that you need to have another microservice that does this aggregation or do what. I'm just saying that even if it's a monolithic code base, if you can start to separate out what you think of as your base API, your core API, and what you think of as the aggregate version of the API, which is optimized for consumers, that starts to bring a lot of method to this madness of API design and the iteration and evolution that you're doing as well, right? GraphQL is a great fit for that second part of the problem. And what GraphQL says is, crazy idea. What if I never had to build an API integration or aggregation endpoint ever? What if I give you an API where you, as an API consumer, could aggregate whatever you want on demand on top of the base resources that I have created? And so I never have to build this for you. You don't have to ask me to build it for you. You just look at the graph and you're like, yep, these are the resources that I want. And so let me just query them. And I get them in the way that I want. And if I want 100 attributes, I'll choose 100 fields. If I want 20 fields, I'll choose 20 fields. So it kind of neatly separates out that problem. And especially in kind of that context of a supergraph, it gives us a way to think about how to use that, right? And now, where is this useful? You can imagine that GraphQL is kind of useful in a bunch of different situations where you're running into this API integration aggregation problem.
We'll be back with our interview with Tanmai in just a moment. Hi, it's me, Robbie. I just wanted to say thank you for listening to the podcast. If you haven't yet given us a review on Apple Podcasts, head over there and give us a 1, 2, 3, 4, 5-star review. Be honest and just say a few words. Maybe you think this was a good episode with Tanmai. Maybe you like one of the episodes and say one of my favorite episodes with Chad Fowler. Or Robbie is just a really interesting host and I dislike listening to it, but I will do it almost weekly because that's how I spend my time walking my dog. Also, if you're walking your dog, send a picture and post it on social media. Listen to the podcast, walking my dog. Also, is there someone you think I should have on the podcast? Shoot me an email to robbie@maintainable.fm. And now let's get back to our interview with Tanmai Gopal. I'm curious about, one of the things that, I've not done a lot of GraphQL work myself, but, in some scenarios, what I've wondered about is like, if you're giving the access to people to be able to query what they want and whether or not they're overloading your system or not, like how do you manage that from how do you put some guardrails around? Like you can only do so much because we're not going to send you 10 gigabytes over the wire to your mobile app. And
so it's important to kind of separate out like two aspects of or two use cases of GraphQL, right? So let's talk about that use case of GraphQL where all you had before you had GraphQL is you had these base APIs. So now what you're saying is, instead of my clients using these base APIs directly, I'm going to give you a way to fetch a composition of these base APIs together. And by definition, that is not going to be worse than you calling those base APIs directly. The reason why this has a potential performance, the reason why, in the way to measure about performance, the metric that you're solving for, if you think about like, what am I solving for here like you're the CIO and you're looking at all of this, like everybody's kind of on this, like, let's build GraphQL, let's do this and let's do that. And you're looking at like, what did we achieve here, people? When you think about what you achieved here, what you do is you get the ability to reduce your latency outside the data center. That's the metric that you're optimizing for. You're basically saying that a client that sits outside my data center, outside my network, like, when I say outside my data center, outside my cloud, outside my network, that latency is the thing that you're worried about because that latency is order 100, like that RTT could be like 180 milliseconds, right? So that if like around the world, right? But if you look at that, it's probably between 20 to 200 milliseconds is the worst case that you can get. So optimizing for that number is the performance that you want to get benefit on. What you don't care about is the load on the upstream system because that load would have remained the same even without this aggregation layer. So you kind of don't care about it. And you're not optimizing for that use case, right? You're optimizing the thing that you're looking at is, did I, instead of making 10 calls, each of them taking 200 milliseconds, did I instead make one call that took 200 milliseconds plus 5 for each of those aggregations to happen in network, right? And then just suffer with the one shot 200 millisecond penalty. That's use case one. And then there's another use case of GraphQL where that upstream thing matters a lot, but we can talk about that.
Thinking about maintainability and in particular and existing software, like many developers think architecture choice is kind of like at the early part of a software project. So in the development, like when in the development cycle, do you think it's optimal to start considering something like a super graph approach? Have you seen a lot of examples where existing teams have been able to retrofit and change their paradigm? And what are some patterns that they might explore for doing that?
I think the need is when you realize that the pain that is being caused in your system, or there's a death by 1,000 cuts that's happening because of the lack of API integration aggregation. So that's the sign that you want to look for. If you feel like nobody's suffering because of the lack of API integration or aggregation, and that being self-service, right? If you look at your backlog and your backlog has like 80% of it stuffed with like, give me a shape of the data that's like this, or give me like, add a new field here and give me a new filter on this thing and give me a new like join on this thing. And that's 80% of your backlog. That's a sign that that like API integration is taking up a way like large amount of your time, which it just go do innovation, like build some stuff with AI, like do whatever, right? Like don't do this, right? This is a waste of everybody's time. So Or you're looking at like what I was talking about, where you had that performance concern outside the edge, where you're like, I'm spending too much time on network transfer outside the network, and I want to reduce that, right? So you look at these pain points of API integration aggregation, and then you feel like, I think we need to start thinking about self-serve, like making composability self-serve, as opposed to me creating composition endpoints. I really want to start making composition self-serve for my customers. So that's like the pain point identification. Now, once you do that, your path forward like really depends on kind of the technology stack, et cetera, and stuff that you use. But broadly, it kind of all fits into this idea of the first thing that you want to do is start to approach this from the point of view of just batching. So you have multiple REST API endpoints. Can I create a layer that would make it easy for somebody to just batch multiple endpoint calls together? That's it. Nothing fancy. We already have these endpoints. What is the simplest thing I can glom on in front of my REST API that allows somebody to create relationships between the existing API endpoints? And that way they can just batch, they can just fetch multiple API endpoint things together, right? What's the simplest way that I can go from REST API to not ideal GraphQL API, but a GraphQL API? Like, how can I just solve the batching problem? And that usually becomes the way that people start, which is to say, cool, I've gotten REST API that has 50 endpoints. All I'm going to do is somehow convert these 50 endpoints and say that there's a relationship between the user and account via user ID, and user and last orders via order.user ID. And you just somehow create these stitched things together. And that results in a GraphQL API that allows you to essentially batch them, right? You're essentially just fetching the batch together. And that's the first step. The second step then becomes, all right, now that I've gotten people here, what would a true resource model with relationships and standardized filtering and pagination and sorting and nested filtering and joining, what would a good API look like? And that's the time when you want to really start thinking about, can I start building this GraphQL API directly talking to my data source so that I can go from data model to API model in a more unified way? I can create that right abstraction between my data model and API model, but they're close together. And there's the least amount of impedance mismatch that I have between these two models. And now that really lets you kind of, it's exactly what you were talking about earlier, right? Sometimes you're just like, can I skip this API BS and get to the underlying data model that you have, because that'll be faster for me to understand what's happening. So then you kind of truly start to think about the graph and start to connect it to one level lower, a system that's truly where that domain is residing, and shaving off the abstraction that you wrote 15 years ago, which like is probably not ideal. But you can start with just batching and then go into true composition. And that's a spectrum, right? Like you can gradually unlock that. Does that make sense?
No, that definitely does. And it helps answer, is this a all or nothing proposition? Do you have to like
Yes,
make a full transition, or can you iterate your way or experiment with some key areas of your API and try to like consolidate that a little bit more? And maybe
exactly.
even you mentioned like the scenario where you might, for those listening, that might be working on a lot of custom endpoints for specific customers or clients or
Yep,
partners that they're working with, like maybe this is a way to experiment with that. Like, hey, can we organize some stuff a little bit differently versus creating yet another, say, RESTful API endpoint? So you could test it out maybe in that scenario as well. And then that could unlock it. And maybe you can retrofit some of your other existing clients and vendors to get them
exactly.
on board to use it as well. So I can see that.
Exactly.
I can see how that can kind of see a map out. I'm gonna do a little bit more research on this and get back to you on this. Take a moment to also plug your organization, Hasura. Can you provide listeners with who might be unfamiliar with your platform with a little bit of an
Absolutely.
introduction and how this all kind of relates to, I'm assuming, to Supergraphs?
Many years ago, we were like, man, this building APIs thing is a pain. It feels like we're just doing the same thing over and over again. I have the model. Why am I building a CRUD endpoint and writing all these aggregations and like again and it's just feels like repeat code. Like the principle is the same. I've done the hard work of designing my models. I've done the hard work of writing units of code that represent my business logic. Why am I having to build and maintain an API and then do aggregations and stuff like that? And so we launched Hasura, the first version of our GraphQL engine, as an open source project, which essentially introspected your domain and derived the graph from that domain. And so we started off with Postgres and we said, if you give us a Postgres database, we'll introspect that Postgres database and create an API and a graph on that Postgres database. And what you can do is you can customize that. Like, for example, your API model does not often map to your data model directly, right? And so you can customize the way that mapping happens. And that way you get a GraphQL API on your Postgres. And that's how we started with many years ago, 5-6 years ago. And then gradually it became really popular with developers and people started using it to build all kinds of things. And then we started adding support for more and more different kinds of systems that we could introspect. So today, for example, you can introspect a whole variety of databases. It could be SQL, it could be NoSQL, but you can also introspect code. So for example, if you give it TypeScript functions, we'll introspect the TypeScript function and bring that as an entity in the supergraph. And now you just have to create a relationship between this TypeScript function or something else. So you can say, here's my user model that comes from the database, but there's something called currency that comes from a TypeScript function that's connected to this, right? So you create these relationships between your domain that you're introspecting. You can introspect APIs. So you have an open API that already exists or gRPC that already exists. We can introspect that schema and again, bring that into the supergraph, right? So Hasura as a platform has now kind of evolved into this idea of saying, you have many different teams, you have many different developers, they all have different domains, they have APIs, maybe they have code, whatever they have, we now have a platform that introspects their domain, brings it up into the supergraph, allows people to kind of create relationships, and then Hasura just maintains the API for them. So now, for example, if you are the entire API, the standardization of filtering, sorting, pagination, et cetera, is all maintained and standardized by Hasura itself. So tomorrow now, if you added a new field to a model, that will automatically show up in the API. You just run a CI/CD step, and then it automatically your API gets updated. Let's say you remove a field. When you run the CI/CD, we'll fail the CI/CD and we'll tell you, Robbie, don't do this, bad idea. You're going to break the API. And so then what you have to do is you go in and say, well, I'm going to deprecate this older field and mark it as deprecated so that people stop using it. And then I'm going to introduce this new field. And now that shows up in the API, where if you try to use the API documentation says, hey, first name, last name is deprecated. Now we have a new field called name, which aggregates these two. And then you look at the analytics and say, right, everybody has finally stopped using first name, last name. I can take it off my API. And now we're just going to use name going forward. So this entire kind of delivery and management of the API is taken care of by us. And you, as a domain owner, just deal with your database or deal with your code or deal with your API or whatever your domain is. You just work on that. It automatically gets published into a supergraph automatically. So that's what the tech does. We're in 5 of the Fortune 10 are our customers, about 50 of the Fortune 100 are. We have open source footprint there. Super thankful and glad to be working with all sorts of people, whether enterprise or developers, small applications, large applications. It's been fascinating to see how much larger this problem was than we thought it was. We thought it was like a personal itch that we were solving, and then it turns out, oh man, this is crazy. So that's the company.
Hey folks, it's me, Robbie. Just wanted to take a moment to plug my own company, Planet Argon. We're a Ruby on Rails consultancy, and we help companies with existing Ruby on Rails applications make them better and more maintainable. That's right. We're here to help you and your team modernize your applications so you can start thinking about, hey, Rails 8's coming out later this year, Rails World, and we're still running on Rails 4.2. Oh boy. Sound like you? Maybe Rails 5.1? You're not really sure how to get there? Maybe we can help shine a light on a path forward. Get in touch with us at planetargon.com. Again, that's planetargon.com. And tell me that we sent you to planetargon.com. And now, back to the show. Nice. I'll definitely include links for folks in the show notes. I'm curious, just trying to wrap my head around a little bit around this. So if you connected directly, say, to a database like Postgres, for example, and it generates this, where do you often advocate for where business logic might exist in terms of, like I work in an area where, we might rely on like an ORM in our web app or something like that. And so that's where the kind of guardrails are to some degree. I had to learn many years ago to trust the ORM because I used to be a lot more database focused and do a lot more stuff like store procedures and triggers and stuff in the database. And so I'm just curious, like, is that where you kind of mentioned, like, you can do things in TypeScript or something like that, or depending on the programming language that you're using?
Yep, exactly. So the way that we kind of help you architect the system is to separate your domain into methods that you're running on TypeScript and resources that are derived that are as close to the database that you're using as possible. And so if you think about the business logic that comes up in these cases, right? Business logic is broadly on two sides. One is access control and authorization on reads, and the other is validations or transactions on the write. That's kind of where your business logic is. Everything else is API, but like the core of it is access control or custom transactions and methods, right? So custom transactions, methods, stuff like that goes directly into your TypeScript pieces of code that you just write, and then we bring that in as into the graph. On the access control side, what we invested on a few years ago and that really paid off is, have you heard of a system called row-level security in databases?
Yes.
It's a very fine-grained model of security that lets you take any particular model and specify what the security access control rules on that model are. What we did was we brought that up into the graph layer. So now you can look at a user model and say, this user is accessible by anybody with a JOT claim called guest. If the user ID is equal to the session ID, and if user dot blocklisted doesn't contain the current ID, and blocklisted could be a totally different part of the graph. It's not even, that data is not even in the same Postgres. So you kind of get this ability to create these access control rules on any of your models and resources. And these access control rules themselves are properties of the graph. And that kind of authorization system is what you use to secure each of the resources that you have. And then Hasura kind of just generates the API on top of that.
I see.
And so that way you get rid of like 80% of the code that you were writing that was essentially just checking a claim, pushing a where clause inside the database.
Well, definitely, I'm sure we can talk a lot about this and get into the weeds here, but in the spirit of time, a couple of things I wanted to quickly pivot over to. I understand that you have a conference coming up in August, I believe. Tell us a little bit about that.
Our annual user conference. So we showcase our customers, our enterprise customers, our customers who are building cutting edge kind of applications themselves and learning from kind of their reference architectures, their patterns on how they've been using Hasura and what kind of learnings they have to share with the rest of the user community. So it's great for people who want to try to get into Hasura, understand what it is, learn from kind of what other people are doing. And then, of course, we use it as a time to kind of launch key capabilities in the product. And so there's a bunch of surprise things that are going to come up in August. And for any of you who are here who are going to be at the AI Engineering Summit in San Francisco in June, we're going to be launching some very interesting things for LLMs and data access. And it turns out it's the same version of the problem. But if you're going to be around here, would love to see that in June as well.
Is there a non-software, non-technical book that you find yourself recommending to peers?
I've been reading a lot of interesting science fiction these days. And so there are a few authors that I would recommend. N.K. Jemisin and her trilogy, it's called the Broken Earth Trilogy. Naomi Novik has a bunch of different books, everything from Uprooted to the Scholomance trilogy that is absolutely amazing. Martha Wells and Murderbot series. I'm sure if you're in it, you've heard it. It's absolutely phenomenal. One of the most fun, like tiny novellas that has like a 10 series kind of thing. That's just a fascinating read. But you should definitely try out these three authors if you're into science fiction at all. Very different, good hard sci-fi sometimes, but it's very different from the kind of science fiction that we might have read earlier. So it's very interesting.
Nice. I'll definitely include links for everybody in the show notes if we can do some reading over the summer. And where can listeners best follow your thoughts and ruminations about software engineering online?
I'm good on Twitter and LinkedIn. I'm a little bit slow sometimes, but if you hit me up there, it's great. And then oftentimes if you're getting into conversation, I'm available on email as well. But Twitter and LinkedIn is just the easiest place to reach out.
Wonderful. Well, definitely include links to all that in the show notes for everybody. And with that, it's been such a delight having you join us on Maintainable, Tanmai. Thank you so much for stopping by to talk shop with us.
Thank you for having me, everybody. Thanks, Robbie.